So today we are going to be learning two more additional ways that we can represent quantitative data. This will be the last new stuff, and then you guys have a quiz on Friday, just a reminder. So the first one we're going to learn is called an ogive. It's pronounced ogive, not ogive. It's an ogive. And this is another line graph. It's similar to frequency polygon, but it's different. So you got to make sure you understand the differences between those. It's similar because it is still a line graph. So you're going to plot your points and connect the dots. Where the x values, or the x-axis labels, are the upper class limits, so the second number in your interval. And the y values are the cumulative frequency, or the cumulative relative frequency. So it just depends on if we're asking for a frequency ogive, you would use the cumulative frequency. If we're asking for a relative frequency ogive, you'd use the cumulative relative frequency. Ogive, not ogive. So how to construct an ogive? You first have to compute those cumulative frequencies. And then you would plot the cumulative frequencies above the upper class limit. So again, cumulative frequency would be your y, upper class limits is your x. Huh? Okay. Okay. Then you connect the points with straight lines, just like you did for the frequency polygon. Okay, so we're going to do an example. So I give you our intervals, our classes here. So again, the second numbers, these upper class limits. So upper class limits are your x-axis labels. And then when we're doing our cumulative frequency, we take our frequency and we just keep adding as we go down. So then we'd have 28.9 plus 35.7, which will be 64.6. Then plus 35.1, and then plus 24.7. Okay, so this is like what we did on Thursday. Just keep adding as you go down. Then relative frequency is where we take our frequencies divided by the total. So if we add up all our frequencies, we get our 124.4. So you would do the 28.9 divided by 124.4, and so on. You do that for each frequency. We've done this before. You get 0.23, 0.29, 0.28, and 0.20. And then cumulative relative frequency. Again, what we did on Thursday, where you start with your first relative frequency and then you just keep adding as you go through your table. So we'd start with 0.23, then we would add 0.29, then we'd add 0.28, and then we'd add 0.20. Okay, so if we do for our first one a frequency ogive, ladies, okay. Frequency ogive, our x-axis labels are going to be the upper class limits, so we would still label it as age because that's what our numbers are representing, but then we use our upper class limits, so 34, 44, 54, and 64. And then since it's a frequency ogive, our y-axis is going to be the cumulative frequency. Ogives are always cumulative. So our cumulative frequency has to go up to 124.4. So we'll just make it, we'll do 125. Go up by 25s. And then we just plot our points. So our first one for our first interval, above 34, we'd have our first cumulative frequency, which is 28.9. Then over 44, our next cumulative frequency is 64.6. Then above 54 is 99.7. And above 64 is 124.4. Whoops, my title is in my way. So then we connect our dots. And that is your frequency ogive. So again, since it's cumulative frequency, ogives should always either be increasing or constant. They should never go down because the cumulative frequency will never decrease. You're either adding 0, which just means it'll stay the same, or you're adding a number to make it increase. Okay, so then for the relative frequency ogive, it'll be very similar, but our y-axis labels will just be the cumulative relative frequency. So relative frequency ogive. So our x-axis labels will still be those upper class limits. This will represent the age. Then our y-axis will be the cumulative or relative frequency. And so this one, your y-axis should always go up to 1 because remember cumulative relative frequency should always, that last one should always be 1 or very close to it. So our top label here should be 1. We can go up by 0.25. Oh, whoops, I did too many things. And again, if you want to do your cumulative relative frequency in terms of percents instead of decimals, that's fine too. You just go up to 100% instead of, that should be a, and then 1.0 or just 1. So our first cumulative relative frequency is the 0.23. So we'd have 34.23, then 44.52, 54.80, and then 64 and 1. Okay, again, we use our lower class limits and then cumulative frequency or relative frequency. Do you guys have a question back there? Avery, question? Okay. So I can move on. I'm moving on. Here I go. Okay. The last thing we're going to talk about today is a time series graph. Oh, this one's pretty straightforward. This is just if you have data collected over time. When the variable is measured at different points in time, the data is time series, hence time series graphs. Again, creative naming here. So when our data is collected over time, it's natural to plot this time series data against time. And again, it's called a time series graph. So plotting against time just means your x value will be the time. So whatever units it is, sometimes it's months, sometimes it's years, sometimes it's hours, minutes, whatever it is, whatever your time intervals are. And then your y would just be whatever the value is, whatever your data value is that matches up with the time. So time series plots are used to see trends over time. And it can help identify either long-term trends and or regularly occurring trends. So a long-term trend would be like if it's increasing over the entire time, it keeps going up or it keeps going down. Regularly occurring trends would be if it goes like up and down, then up and down, then up and down as you go through your year, go through the months. Okay, so here I just have an example of a time series graph. Again, it would just be whatever the data is that I give to you. The time would always go on your x-axis. Just label it with whatever the units are. So in this case, it's a date in time. And then whatever your data value is that goes with the time would be labeled on your y-axis. You plot your points and connect your points with straight lines as you go throughout your data. So commenting on the trend of the data, you can do a general trend, or you can say like it was increasing from, can't read it on there, March 03, so increasing from March 03 to January 04. And then it slowly started decreasing over time. There was a little bit of an increase kind of here in the middle, but overall, for the rest of your data, it was decreasing. Then decrease over time through February 05. Okay, so just commenting on literally what's happening in your graph. All right. Any questions? So the main thing, again, ogives and frequency polygons look similar, but how you label your x and y axis is different. So just make sure you remember those differences. So there is a self-assessment on the back page there, so go ahead and do that. And then raise your hand, I'll check it, give you the homework, answer keys on the board. And that's what you have the rest of the time to do.